Good morning all, it's Postbag. These envelopes are all grey these days, aren't they? Not yellow anymore. It's a shame. Right, let's start with this one. Now this one's already open because I wanted the Peltier element for my refrigeration video I did recently. So let's just drag out the remaining bits. And it's this lot. Right, what do we have here? Another hygrometer. But this one has a wire, and I'm not sure whether the sensor there is just for temperature or whether it's for humidity as well. Probably just for temperature, and the humidity sensor will be in here. Now, fortunately, I went to the pound shop the other day and got some batteries, so I can get that thing up and running now. A couple of 9-volt battery holders, very, very primitive design. Just got the positive and negative connections there, and a little retaining clip. And these ones have a 2.1mm plug on them, but I'm just going to cut that off and cut the wires really short. That's going to be for my hygrometer project, the one I'm making myself, a couple of those. What's this? This is a Christmas tree kit. I'll open that in a minute. And these are all humidity sensors. So let's put batteries in this temperature and humidity sensor. Well, I presume they go face down, so let's shove them in. Yeah, that's good, that works. 51% humidity. Wow, 26 degrees in here. I think the heating's on. So let's take a look inside this external thing. Ah, no, that looks like it's got both the temperature and humidity elements in there. You can never have too many hygrometers, that's what I say. Now they're not quite in agreement with each other yet. These three were all in one room, so this one's always read a bit high. This one should settle down and match these, I would have thought, in time. Now, talking of hygrometers, here's my hygrometer project. It's an Arduino with one of these little humidity sensors. This one's the SI7021 and an OLED. Let's power it up. Well now actually I can use one of these 9-volt battery boxes with the 2.1mm connector and plug it in there because the Arduino has its own 5-volt regulator. So let's plug that all in. Now the only thing that could go wrong is if this isn't center positive, but everything is center positive these days, so I'm just going to go for it. Yes, that's lit up, that's fine. What's the OLED saying? Okay, so that's giving me a humidity reading from this sensor. I've still got this level shifter board in, which is not needed because these sensor boards have their own level shifters on them. So that's all working well. And now I'll open these. Right, this one is, well, it's on the same style board. It's called the GY21 board, and it's another humidity sensor. I think it's the bottom one there, the HTU21 on that board. Right, the next one is another temperature and humidity sensor, and this one is an SHT3X. I've got a feeling it's the SHT30 it is, I think. So that's another one there. That's got 6 pins, not quite sure why. And in here, and also in here, because I think I accidentally ordered 2 by mistake, so we'll just look at one of those. I think it's the BMP 280. Now that's a temperature, humidity and pressure sensor. Yeah, that's the BME/BMP 280. That's got a little 4-pin connector as well. So let's have a look at all these in close-up. So I've got the original SI7021 here. This seems to be a general purpose board which can take multiple sensors, so all the names are on there. This one is the HTU21, I'm pretty sure it's that. This is the SHT30, and this is the BMP 280. Now I've drawn a little chart to show how these things are all different. So here's my chart. I drew this a few days ago. The SHT30 is a plus or minus 3% device. It's 2.4 volts to 5.5, so that shouldn't have any level shifter circuitry on it. No, it doesn't appear to have. It's got a couple of other pins, this AL and AD, and I think that's why they supplied the 6-pin connector. I'm not sure quite what those are yet. Also, I've written on here the addresses in hexadecimal for I2C because I wanted to know whether I could put multiple different ones of these on the same bus. Okay, so the HTU21D is a plus or minus 2%, so it looks like a slightly tighter tolerance. Now, I haven't written in the voltage for some reason on there, but if I flip this one over, it does have the level shifting circuits on it, so I presume it's a 3.3 volt or something around that. It's some range encompassing 3.3, but not going up to 5. So yeah, and the hexadecimal address for I2C on that is 40. Now that's the same as the SI7021, so they couldn't be put on the same bus unless there's a method of changing the I2C address on that particular sensor. SI7021 is a plus or minus 3%. It's 1.9 volts to 3.6, so it does have the level shifting circuitry on the back there, which is this little tiny 6-pin chip here, which that is 6-pin, isn't it? Yeah, can't quite see the other 3 pins, but that's 6-pin, so that's the dual MOSFET. Again, the low voltage range, hexadecimal 40 for the I2C address, and the BME280 is a plus or minus 3%. This also has a pressure sensor in it as well. Also I2C, but it has a different set of addresses. It can be 76 or 77. You probably have to link it. Now, is there a linking pad on there? Oh, there is a pad on there, a 3-way pad. You can just make out the gold contacts there, so maybe that's the I2C address. 1.7 volts to 3.6. Now, the other thing about these sensors which interested me is the pin arrangement, and these are all the same. They're V-in, ground, SCL, SDA. This one's the same, V-in, ground, SCL, SDA. This one's the same, and this one the same. They're all arranged the same. Now, I don't think it's any secret that what I'm planning to do is attach this sensor directly onto the front of the display here, because on this project, let me just zoom out again. On this project here, although these two cables look completely separate, they're actually exactly the same signals. They are VCC ground, SCL and SDA. I've just picked them off different points on the Arduino, but they're actually duplicates. So this sensor, now I know it doesn't need this level shifting board, could, if the pin arrangements of the display were the same as the sensor, be completely stuck together, the sensor sitting directly on the front of the display. Let's close in on that again. So the sensor goes VCC ground SCL SDA. The problem is the display, or this one, goes ground VCC SCL SDA. However, there is another display coming. I hope it's in a package I opened today, which has VCC and ground swapped over, so they will be a direct and perfect fit. And then it's simply a case of taking the sensor and sticking it on the front of the display. That will be pretty neat. So with one of these sensors actually attached to the front of the display, and then an Arduino Pro Mini sandwiched pretty close behind that to replace the Arduino Uno, this is going to be a very small stack of boards. And that's why I wanted these 9-volt battery boxes, because I'm going to stick, probably with double-sided sticky pads, the Pro Mini onto the 9-volt battery box, and then these wires will attach to the raw, where are they? Yeah, the raw and ground inputs, which are up there, and then the hygrometer will be a tiny little thing, 9-volt battery box, CPU board, display, and the sensor stuck actually on the display. It'll be neat. So here's the hygrometer with the cable attached to it. We now know that both sensors are in that cable. This is a mini digital LCD thermometer, hygrometer, humidity, temperature meter indoor, just $1.99. Free shipping from Alice 110 1983. Now all these things in this envelope were Alice 110 1983. The two battery boxes are 2 pieces new 9-volt battery holder box case wire plug, 5.5, that's the outer dimension of the plug, 2.1mm, that's the inner dimension for Arduino. Well, yes, I used it for the Arduino, didn't I? So they're right. It is for Arduino. Price $1.29, free shipping. Alice again. And now the sensors. This one is the SHT30 or SHT30D temperature humidity sensor breakout weather for Arduino again. $4.22 free shipping. Now this one is the one that runs from 2.4 to 5.5 volts. So it doesn't need level shifters. They're not on the board. It's a 3% sensor. This one, HTU21D temperature and humidity sensor breakout board module. This one, $2.77 free shipping, Alice. Now this one is the 2% sensor. It has the level shifting components on the board. So that, for a 2% sensor, seems pretty good value. Right, this one is the BME 280 breakout temperature humidity barometric pressure. This also has pressure, so this is a more advanced sensor. BME 280 digital sensor module, $4.50 free shipping. And from my chart, this is a 3% on the humidity. It has the level shifting components on the back of the board. And the final item in this package from Alice is this, and this is Christmas themed. It's a Christmas tree. Let's just see how this works. Yeah, so this one has a slot in the top, that one has a slot in the bottom. So they attach, oops, like, got to get this to work. Yes, like that. So we have a 4-way Christmas tree, and that sits on a base, which is also supplied. Nice boards actually, all routed and cut, so everything sort of fits together neatly. That's pretty neat. I think that sits on a battery box, which is there. But there's also a USB cable, so they've gone for ubiquitous USB, and that plugs into, is it that? Yes, that's the little socket for it. This is a small version of the plug. I can't remember what the dimensions of that are. I think it's 1.3mm for the pin. I don't know what, I can't remember what the outer dimension is. So yeah, that can be powered by USB. Now, interestingly, as far as I'm aware, yes, I think it's right. This is a simple 3-transistor circuit. Here are the 3 transistors. And so this is using the, oh no, what was it called now? A ring oscillator, a 3-stage ring oscillator. So it's a very simple circuit, 3 transistors, 3 capacitors, some resistors presumably in there, and lots of LEDs. And it was the ring oscillator that I used in my, well, I built a 19-stage ring oscillator, which I had in a previous video. I'll just bring that in because I changed the color of the LEDs on that. Yes, this was the 19-stage ring oscillator, and you can see on here that now that I've put alternate red and green LEDs on, it sort of does a green rotation and a red rotation. And this also works with the randomizer feedback connection, which makes them all nice and random. That, I think, will make a nicer Christmas decoration. And yes, I did get the idea for making this from this Christmas tree. So I'm seriously considering doing a real-time kit build on this. It's going to be like a 1-hour-long video with like Christmassy music and mince pies. It's just an idea. And so this item is Christmas trees. Well, one of them. LED DIY kit, professional red-green flash LED circuit. $3.92. Great prices on these things. Free shipping, and Alice 110 1983. Right, let's move on. What's this one in here? Right, okay. These 10 packs are actually those little level shifting boards. I'll open one up and we'll have a look at that again in a minute. So all those are the same. And these are some little 4-way headers, female headers. So let's get in close on these two. So these are 10 of these little level shifting boards. Now I don't really need them. well, certainly not for the hygrometer project, because all of the sensors either have the level shifting components on the sensor board, so they're a bit surplus really. Yeah, bad timing really on those. And these are kind of for the same thing. I saw them with this sort of nice right angle bend in it, and I was thinking for things like the OLED to give myself an option to have a plug and socket arrangement so it's not permanently attached to the Arduino Pro Mini. I thought I'd get some of these 4-way female headers, again for I2C ground VCC, or VCC ground as it will be on the new display, SCL and SDA. So that's what those are. So the level shifters are 10 pieces IIC, I squared, CI2C, it's all the same. Level conversion module sensor, 5 volt to 3 volt. And of course it has the, I was going to point at the screen then, but can't do that when I'm doing this. I can point to this. I can point to the big one. No, I can't. But it has the 5 to 3 volt regulator on there as well to actually provide power to the sensor. So 10 of these for $5.25. Free shipping again from Alice. And these headers are 20 pieces, 2.54mm pitch, so that's 0.1 inch. 1 times 4-pin header right angle female single row socket connector, $4.07 free shipping. Alice again. Okay, another grey one. Let's see what's in here. Okay, it's an LED controller, but I don't think it's for the WS2812 or WS2811. I think it's for a standard... I don't even know whether it's RGB. Not sure what this is. Right, this is definitely for RGB LED strips. There are 4 connections up there, so that'll be ground, red, green and blue, of course. Mode and demo, so that's the pattern type. Speed and a color selector. These are little tactile switches on the back of the board, unlike the silly switches on the other side, which were on that other one I got. 12 to 24 volts in, and that's on a 2.1mm. So yeah, it's a little microcontroller, demo controller for standard RGB LED strips. I don't think I've got any of those. I can't even remember why I bought this, so I'm going to have to get one of these sort of reels of tape RGB LEDs, and hopefully it'll come with a connector that will interface with that. So yes, I bought this one way back in April of 2016. I bought it because it was cheap, 73 US cents, so that would be one of these Canadian 99 cents things, I think, about 50p, which is remarkable for that. I mean, it's a computer, isn't it? There's a computer in there for 50p. So yes, I'll have to find something similar. So I'll do a search now, and then I'll have a link which I can put in the links, which will appear in the description below. Right, here's one that's very similar looking. This one appears to be just 12 volts, not the 12 to 24, which it says on mine. But anyway, this is a one-piece 12-volt mini controller dimmer connector for 3528 or 5050 RGB LED strip with 3 keys. 99 Canadian cents, 74 US cents, about 50p. Free shipping, and this one is sell best every day. Right, can this one please be that OLED display, because I really want that. I don't think it is. Right, these are 3 of 4 ideal diodes that I bought following buying the ideal die, which turned out to not be much of an ideal diode. So here we have, well, it's interesting, there are 2 MOSFETs on this one and 1 on this, so they're just different current specs. There's a lot of discrete components on these 2 boards, including a 5-pin SOT23 which has been scratched, so you can't see what it is, which is a real irritation, but I'm quite determined to find out what it is. But lots of components on those. This one is very different. It's got a special purpose controller. I think it's a linear technology chip. It's a special purpose ideal diode controller. It also has 4 MOSFETs on here. Let me just get in a bit closer on that one. Yeah, so it's an LT device. I don't know whether we can tell from the markings on the chip what the number is, but the four MOSFETs, I think these two are in parallel. These two are in parallel, but you can see they're all the same MOSFET from you can see from the direction of the printing that they're facing each other. So they're either connected source to source or drain to drain. And down in this corner, whoops, there's an on-off control. So I think what this can be is it's an ideal diode one way, and then I think you can switch on and off the other way, or maybe you can switch on. Oh, I don't know. I can't remember. But the application or the datasheet for this chip explained what all this was and what the purpose of this on-off signal is. I don't think I'm going to go into it in too much detail right now, but we'll look at that when the fourth one comes in. The fourth one uses a different chip again. I don't think it's linear technology. I think it's something else. But I don't think these use an ideal diode controller. I got a funny suspicion that chip there might even be something like an op-amp. Because I've seen a circuit on Google Images which has quite a lot of sort of support components, which has an op-amp in it. So it'll be definitely interesting investigating all these things. These two have this arrangement which I didn't particularly like, where out and in are on the same side of the board, and ground isn't even in the middle of them. It's not an ideal layout. This one, however, is better. It's got in and out with a ground and another ground down there, but which is a smaller hole, which is a bit strange. But at least it's in on one side, out on the other. So I think I prefer the layout of this one, even if it doesn't turn out to be ideal for what I want it for. Right, I won't go into these individual listings right now, because I can do a more detailed thing on this when the fourth one comes in. But they are, the one with the four MOSFETs is an LTC 4359 15 amp solar charging anti-reverse irrigation ideal diode module controller, which has this on and off thing, which I'm not quite sure what it is yet. That was quite expensive, $10.30 for that. I guess it has the four MOSFETs on it. And these two were the 8 amp and the 15 amp solar panel battery charging ideal diode anti-reverse irrigation thing. $4.30 for the 8 amp and $4.90 for the 15 amp. These all came from Ayanhu81. I'm sure it's free shipping on all of those. Now let me just scroll up a little bit. This one is Xinyangxi, and it's a 15 amp diode solar, the counterattack filling and charging protection from irrigat. Nonsense! But that one is yet to come in. That will be $4.49. And again, this has the in on one side, out on the other, all the same size holes, which I particularly like. Two MOSFETs on there, and a different controller on there. It's a little SOT23, I think. So I'll have to see what that is when it comes in, but I'm kind of feeling this might be the best one. And at $4.49 instead of $10.30, it is a better price. Right, one more, and I think I can feel what this is. Yes, it's the... now, these are JST connectors, 6-pin, and they are the XH type. Now, these are for the little JST 6-pin connector on these PIC programming boards. The first one I bought, I modified and put a right-angled header on there. But for people who don't want to modify it, it wasn't particularly easy unsoldering all these pins. The idea will be to use one of these JSTs. You probably saw in a recent Postbag that I bought the wrong size one. Finally, the correct size one has come in, and is it a perfect fit? It's quite a tight fit, but yeah, that fits fine. And then the idea is that I'll cut that reasonably short, I think, solder on a 6-pin header, so it'll end up being the same as that, but just on the end of a short length of wire. Put some heat shrink on 5 of these. I'll probably use black. One of them I'll use red, which will be a pin 1 marker, and then that will be for the PIC programmer. So here are the two PIC programmers. So when that header is soldered onto there, you'll be able to plug in either the PIC kit 2, there's the pin 1 marker, or the PIC kit 3. It won't really matter which one you use. And I think I've come to the decision that I want to do these tutorials, these PIC tutorials, using IDE version 8, not version 10, because version 10 is just big and unwieldy. Version 8 is nice and simple, easy to use. The only problem with version 8 is that it's now obsolete. It is still available though, so I'm going to have to just hope that it remains available, and I want to use that for my tutorials. Right, see if I can cram all that in this storage box, which has the PIC programmers and the 2 demo boards and some NeoPixel rings, all ready for the PIC tutorials. Good. So these are 10 pieces, 5S1P. Now that means 5 lithium cells in series, because these are basically used for balanced charging, but they, for me, are going to be used for that programming header. 5S1P, 5 cells in series, 1 cell in parallel. It's pretty meaningless for my purpose. Silicon, they're not silicon, they're standard PVC, I think. Coated, balanced charge cable, wire, JST XH, XH importantly being the 0.1 inch pitch, connector male female plug. $2.99 for 10, that's pretty good. Oh, and 59 cents shipping. This came from Sassi River 2009. And so these are most of, I think, today's Postbag items. So I'm going to spend a bit longer today on the robot kit build. I'm just peeling this double-sided sticky stuff off. No, I don't suppose this really matters what direction this goes. Oh, it's going to go that way, isn't it? So let's stick that on there. Oh, that's not quite centered. Stick it on there. That looks pretty good. That's got a peel sheet on it, which will cut down the light entering the solar panel. No sun today, although it's quite bright. Let's peel that off and see if the motor runs. They do warn you in this construction manual actually that unless you have absolutely full-on sun, the motor won't run. So maybe this isn't the kit for people in the United Kingdom. However, big torch. Yeah. That's running nice. Good. That works. Well, now it's saying I've got to get these wires tucked behind these little clips in the plastic. Well, that's not going to be at all easy, is it? I'm going to have to try and push that down. Oh, actually, yes, that has gone. I don't suppose it matters which one goes on which side, so that's the negative. Now let's try doing the positive. Push that down behind that clip, trying not to destroy the integrity of the insulation in the process. I think I've managed it. Oh, that's far enough for today. Hope you enjoyed this video, and if you did, there are a couple more up here which you may also enjoy. If you want to subscribe to this channel, then click my up-to-date face. And Postbags are funded by Patreon. Thanks ever so much to everyone who donates via Patreon. If you'd like to be a Patreon donator, then click this icon here. Like or dislike with the buttons below the video. Cheerio.